Hello, everyone. In this video, we aim to introduce our latest research on handwriting generation. The title of our research is Disentangling Writer and Character Styles for Handwriting Generation. Let's begin. First introduce the research background. Narrating handwritten characters is a highly interesting AIGC task with extensive practical applications: font-aided design and writing robot. For example, the recently released GB 18030 Chinese character set contains more than 80,000 Chinese characters. And the most commonly used Chinese characters are 3,755. If we want to design a set of our own exclusive fonts, the price is very high. Insert a concrete example here. It took a blogger of a video website 18 hours to write more than 7,000 words, among which 13 pens were spent. Through the character generation model, a full set of fonts can be generated with only a few handwritten references. We believe this is very meaningful. With this objective in mind, we intend to propose an approach that generates handwritings automatically. As online handwritings in sequence mode provides more rich writing information than offline character images. We think producing offline handwriting that retains the trajectory order holds more promising application values. It is not practical for each writer to provide a large number of reference samples, and our approach usually can only get a few samples. Thus, the key challenges of this task lie in how to obtain discriminative style features from a limited number of character samples. After extracting style features, how to effectively integrate content and style features to accurately depict all points of the character is also a non-trivial problem. Previous works usually simply concatenate the style vector obtained from a CNN or LSTM encoder with a character embedding. Then fed the fused feature into the RNN decoder to generate stylized online characters. However, these methods mainly focus on the overall writing style, thus overlooking the detailed style inconsistencies between characters produced by the same writer. Next, let's dive into the method part. We observe that usually, two distinct writing styles exist in personal handwriting. Firstly, the handwriting of the same writer has an overall style commonality, and each character presents consistent slant and aspect ratio. And the style commonality of different writers is different. We refer to this characteristic as the writer-wise style since it is useful in identifying different writers. Secondly, apart from the overall style, different characters from the same writer have different styles in details. For instance, in the top right of the figure, both Black and Jia have the same four-dot-radical character structure, however, they present slight differences such as stroke length, position, and curvature. We name this subtle pattern as character-wise style. Inspired by the above observations, we propose to decouple the writer-wise and the character-wise style from personal handwritings, hoping to improve the ability to imitate the writer's handwriting style. After learning the style information, unlike the previous methods of simply putting style and content features together, we use the content as the query to adaptively capture the style information, achieving efficient integration of style and content. In this paper, we present the Style Disentangled Transformer, named SDT, for handwriting generation. As shown in the figure, SDT consists of a dual-head style encoder, a content encoder, and a transformer decoder. More specifically, we use the contrastive learning framework to guide each head to focus on the writer-wise and character-wise styles, respectively, and effectively integrate the content and style information via the transformer decoder to generate realistic online characters progressively. For the writer-wise style learning, we propose to align the style features from the same writer to explicitly encourage the writer head to learn the style commonalities. To this end, we take characters written by the same person as positive pairs and those from different writers as negative samples. As shown in the figure, we develop a new writer NCE loss to learn a feature space where the style features from the same writer are closer than those from different writers. As for the character-wise style learning, we propose an unsupervised contrastive learning objective known as glyph NCE to learn more detailed style patterns. As illustrated in figure, we independently sampled the positive pair, i.e., O and O+, within the first character, while the negative O is sampled from another character. Our sampling strategy randomly selects a small subset of patches containing stroke details, following a uniform distribution. Specifically, we conduct sampling over the sequential patch tokens obtained from the glyph head. After obtaining the two style features, how to efficiently integrate them with the content feature learned by the content encoder, this is the question that needs to be answered. In order to solve this problem, at any decoding time t, we regard the content feature q as the initial point and then form a new content context, q, y underscore, t1, by combining the past generated trajectory points, y underscore 1, y underscore, t1. Next, the content context is regarded as a query vector, and the style information is regarded as a key and value vector. Under the fusion of the cross-attention mechanism, content context and two styles of information are dynamically aggregated in turn. We will show the experimental results in the next section. We first evaluate our method on Chinese handwriting generation task. From the quantitative results, our SDT outperforms other methods across all evaluation metrics. Especially, the SDT surpasses the second best by a significant 22.13% in terms of the style score. Keep looking at the qualitative comparisons, we can observe that our approach yields higher quality results in terms of style imitation and structure preservation. Benefit from character-wise style learning, our work is able to recover fine character details. Our method can also be applied to many languages. As shown in the table, our SDT outperforms other competitors in terms of content score and DTW. Continue to analyze visual comparisons. Our method can handle handwritten characters in different languages and ensure the quality of synthetic samples. Especially in indic generation task, the existing methods are easy to generate crashed characters. And our SDT can still maintain the correctness of the character content. Finally, let's make a brief summary of our work. We summarize our contributions in two key aspects. Firstly, SDT is the first to disentangle two-style representations for enhancing online Chinese handwriting generation. Extensive experiments on handwriting datasets in Chinese, English, Japanese, and indic scripts demonstrate its effectiveness and superiority. Secondly, we further develop an offline-to-offline framework that can produce more plausible offline handwritten Chinese characters based on the proposed SDT. In the future, we will explore the efficient style representation of complex characters containing more trajectory and extend SDT to other generative tasks, such as font generation. In conclusion, we have reached the end of our presentation and would like to extend our sincerest thanks for your attention. We are pleased to announce that the code is public at our GitHub. We invite interested parties to utilize this approach to further their own research.